cool. But today, well, this week is Thanksgiving week in the US. I mean, I think we have many reasons to be thankful for in the Lean projects, right? It's amazing that we're just listing here some of the good news that we had since the last community meeting, not in the whole year, right? Since the last community meeting, we released 4.2.0. It has many bug fixes, improvements. The Flow, now Joachim and Kyle are officially members of the Flow. Dan Stahl formalized his paper using Lean 4. A lot was amazing to see all the community support. I mean, everybody helping and making suggestions. And to get things even better, we had this amazing blog post he wrote about using blueprints, how using Lean blueprints, and showing how to navigate the whole tooling, right? It's really impressive. Meta also wrote a really nice blog post about formalizing modern research mathematics in real time. At AWS, the Cedar policy language model, the model for the Cedar policy language in Lean 4 has been released, is open source. Lean is now also a strategic open source project at Amazon since last week. Lean Sets, a project that Josh Krohn developed during the summer at Amazon, is now open source too, right? It allows you to invoke set solvers. It has a verified LRADS checker, right? Written in Lean. It's the performance is very competitive performance. Evgenia and Anton released paper proof, right? I love the demo. I mean, we all loved in the Lean show the demo, and especially we believe this has a lot of potential for teaching. Moth released not just a large language model for Lean that has been fine-tuned for Lean, but also a search engine for searching the mathematical library in natural language. It's so cool to see some users approach to us telling that, oh, we're using this tooling, it's great. I started using Lean a few months ago. Was a pain to keep searching the library, but now with Google, it's super convenient. And as I said, many issues have been fixed, many more will be fixed. We are working on all the issues that are being reported. This is now the team right now. I have 2 new members. There are more people joining. Some of them are here that will be joining in the future. But yes, we're trying to grow the team. But today the focus is the roadmap, right? We try. I think it's really important. We discussed a lot this topic in the flow. That's really important to make the roadmap explicit, set expectations, right? Make clear that everybody understands where the flow is going, what's the vision, the mission, the flow's mission, how we are tracking progress, why we are being so laser focused in the first year, right? And listing all deliverables, right? I mean, everything that we want to deliver in our 5-year mission, right? I invite all of you to read the roadmap. We released it yesterday. We pointed the community yesterday, but we invite all of you to read the roadmap and make sure that you understand the direction we are going, right? What's the vision, right? The vision for Lean, we want Lean being a tool that is super useful for formal mathematics, right? We understand the impact that Lean is having in mathematics, right? We also want Lean to be a software hardware verification tool. The Cedar project at AWS is an example of projects in this domain. We should not forget that Lean is also a programming language, right? We see a lot of potential there. We want to push in this direction, right? We also believe that Lean is a great platform for writing AI for math and code synthesis, right? AI hallucinates, but with formal proofs, you can address this concern, right? There are many groups that believe this is the way to go. And in the future, it's more important to have a language where you have formal proofs that can be machine checked, right, for AI, right, than having a more mainstream programming language. We see also the impact of math and CS education. We want to support that in the flow, right? You're going to see many items in our roadmap is to support education, both in math and computer science, right? We want to have an ecosystem, right, that's diverse, is collaborative, and we want to see Lean as an essential tool for research, development, and education, right? This is the vision that the Flow shares, right? What's the mission, right? We have many challenges, right? I mean, scalability is one of them, right? We want to improve scalability. MathLib is growing really fast, right? We have other projects coming, right? And scalability will be a problem, right? The complexity of the things you're trying to write in Lean is increasing, right? And the scalability becomes a challenge. Usability is another one, right? We lose users, right? There are many people that come. Some of them, I think, for people that are not comfortable engaging in social media like Zulip, is really tough sometimes. I interact with users, they say, oh, I gave up. There were too many usability issues, right? Sometimes, if the person is willing to come to the Zulip community, the community helps a lot, right? And can work around all the usability issues, right? But even when the Zulip community can help, can address, can help onboarding new people, there's also scalability, right? If we have 100 times more people, it's really hard to scale the approach we have right now. And so improving usability, it's really important. Another area is proof automation, right? Not just the automation we want to develop it at the flow, but the one that we want to integrate, right? Later today, Joe Hendricks is going to tell you about the plans for the standards library. And one of them is make sure the standards library comes ready, right? You have the right simple lemmas, you have the right annotations for ASOP and so on. And other automation, right? There are groups developing Duper at CNU. We have Lean Auto coming. There are many pieces of automation coming. And we want to make sure that the libraries are not just full of terms, but they have the right annotations to leverage all this proof automation. Documentation is another big deal, right? We are working on delivering better documentation, authoring tools, right? And improving our own documentation, like the reference manual. We don't want a reference manual when people go to the string section, it's empty, right? There are many gaps there. We want to fill these gaps, right? This is in our roadmap. If you read our roadmap, you're going to find this information there. And we want to support diverse, many different applications, right? We want to support software verification, hardware verification, formal mathematics, software development, AI for math, and so on, right? And one goal for these 5 years is to achieve self-sustainability. You may ask, what does that mean, right? Well, after 5 years, we will transition to a foundation model. That's the goal, right? And after you transition to the foundation model, some of the developers will join corporations that are benefiting from Lean, right? This is very similar to what we see in other projects like Rust and Linux, right? There are Rust developers in many different companies, right? We want the same for Lean. This is the only way to have a healthy ecosystem where the developers are spread over many different corporations. How do we track progress, right? Well, we have 5 markers, right? We're still working on them and refining them, but the goal is to measure Lean adoption and impact. We are tracking the number of users. Right now, we're basically tracking Zulip statistics. Thanks, Rob, for telling us how to do it a few years ago. But we want to do better. We want to track the websites, downloads. We are trying to improve this metric, right? So we realize some people do not go to Zulip, right? Sometimes I learn projects that uses Lean and we're completely unaware of. But for example, Oracle uses Linktree. I had no idea until I met a former Oracle employee at Amazon, right? I had no idea Oracle has used Linktree. Number of courses. Thanks a lot to Patrick and Rob for they prepare all the information for us. It was amazing. We're tracking the number of courses, and we want many courses in the future, right? Because it brings more people. These courses are going to have lecture notes that can help as additional documentation, right? Number of packages. Today's really course, right? We track the number of packages that have the Lean label, right? So Lean 4 label on GitHub. This is a rough approximation. What we really want is Reservoir, the Lean package registry, right? The repository of Lean packages in the future to use it to track this information. We have the overhead factor, right? This one is the one that's we don't even have a scientific way to measure that. So it's basic. We're using feedback. For example, Turnstile, when he finished his first project with Lean, he said, "Whoa, took 20 times longer to write the Lean projects than writing the LaTeX file." Right. The overhead factor is usually measured comparing the size of the informal mathematics, right, with the formal one. But even that, now people are raising, well, if AI is helping you write the formal version, is this the right metric? Maybe what Turnstile said, the time is more important. How long does it take, right? Not the size. Because if the size if the formal text is being filled automatically, it doesn't really matter if it is bigger, right? Okay, we're still working on this metric. We don't have a final answer here. In build time, this one is really solid, right? We have the speed center. We track how long does it take to build Mathlib, how long does it take to compile 1 million lines of Mathlib code. And we have a precise way to do that. It's going to be better and better as we increase, as we have Reservoir and we have more packages that we can use to track this measure, right? And here's a quick update, right? Here we have single core compilation times per 1 million lines of Mathlib code. We measure using the same hardware, AMD, this Ryzen 9, using one core for Linktree with Linktree 0.51.1, right? It took 20.8 hours to compile 1 million lines of Mathlib code. With Lean 4, just after the port was done and Lean 4 was released, was taking 4.3 hours. Now, 4 months later, it's 3.6, it's 16% speed up in 4 months. But more importantly, the multi-core compilation time improved also, right? It's 38% faster, right? It's 10 minutes to compile on this machine. Of course, this is a powerful machine with 16 cores and takes 10 minutes there. It was taking 17 4 months ago. Now, let's go over this section where we mention, we say our first year is going to be laser focused, right? We recognize that many obstacles for wider adoption, right? We say, some of us say there are paper cuts, usability issues, and so on. And our goal for the first year is to address these issues that are preventing more people joining the community, right? That's what we want to address, right? And they cover things like paper cuts, right? There are small issues sometimes, but they're impactful, right? Sometimes they show up as a bad error message, right? For example, David, when he was writing functional programming in Lean, he tried to address some of the bad error messages, saying, look, you may get this crazy error message. He didn't say crazy, but that was what was behind the explanation. You can get this insane error message. This is what it is, right? We want to improve that. We want to avoid having to explain a bad error message to new users, right? And also when you're using Lean for teaching, we don't want professors, teachers, educators to spend time explaining weird behavior instead of explaining math or computer science, right? Another problem is performance, right? Sometimes you have performance problems. Tooling is another big deal. And there are other usability issues. For example, your HIN is currently working on improving the support for well-founded recursion, right? Guessing the lexicographical order, improving the error message. Sometimes is incomprehensible why something didn't work. He's working on providing a report that says, look, this is all we tried automatically. This is why it failed, right? We couldn't prove automatically why your function terminates. And here's that what you can try to address these issues, right? This may feel like it's not important, but it is, right? New users, it helps a lot new users. Someone using Lean as a programming language may not even be aware that why it matters to prove that a function terminates in a system like Lean. User experience documentation, right? I mean, we're trying to refine the user interface, make sure that VS Code, the plugin, works better. We add all the missing features, right? There are many missing features there, right? Features that people expect, right? Documentation authoring tools, right? David is working on, I mean, we're having sneak peeks. We showed some of them in the last community meeting, but soon we are going to have the first release. And this is going to be a game changer. And in the first year, we want to dramatically improve the reference manual. We can't promise it will be perfect, but it will be much better than what it is today. Right? Cloud Build and Reservoir, right? This is also a huge focus. We want Cloud Build for all in packages. We don't want to have special packages, right? Oh, Cloud Build only works for Mathlib. No, it should work for all packages, right? Reservoir will be the package repository, which is not just a repository of packages, right? It will track breakages, right? We want to make sure there's a tool that helps package maintainers to keep everything working together, right? We want a healthy ecosystem. Developing and integrating proof automation is essential, right? We realize that many groups developing proof automation for Lean, we want to support that, right? And making sure the standard library is working really well with all the proof automation that's being developed. The standards library, I'm not going to go in depth because Joe will cover it in the second part. But the goal here is that we really want a standards library that's feature complete, right? It contains proof synthetics for reasoning about the components that are provided in the standards library, right? And we believe this is going to be the foundation for many other packages, right? There's a lot of discussion about the development model, right? For open source projects, usually they are between the Cathedral and the Bazaar models, right? In the Cathedral, everything's centralized. The few contributors, right? High expertise, long release intervals, more structures and planned developments. Lean has historically been a Cathedral, right, style, but it's now starting to have ingredients from the Bazaar model, right? Now we are moving to a short release cycle, right? So I think everybody's seen that the release cycles now are happening every month, right? We're increasing the number of contributors. We have many more contributors now. We're taking more RFCs. We're trying to automate the process, right? It's not going to change, takes time, right? Nothing will happen. This is going to be slow, right? But we want to have a system where the core, we want to avoid the situation where the core becomes unmaintainable, right? One thing that's going to be hard for us to change, at least in the next few years, is to have a structures and plan development model, right? Where there's a clear roadmap where we set the foundations for the future, right? But some people may say, well, cathedral model is bad, but Lean has a superpower that is extensibility, right? Extensibility empowers, allows, enables decentralization. And we believe decentralization fosters ownership, diverse contributions, right? There are many proof automation packages that have been independently developed, right? Aesop is an excellent example, right? It was completely developed by Yannis, right? He didn't have to coordinate with us, very little coordination with us. He has the sense of ownership. He owns that package, right? And we believe this is important. And this is possible because of Lean's extensibility, right? We may feel like in the end, what we're going to have is a collection of cathedrals, right? I mean, Yannis has ownership over Aesop, right? It's his cathedral at this point. And we believe many other packages are going to be like that, right? So extensibility enables the developments to be decentralized, right? But we want to go even better, right? We want to provide better tooling, right? We can improve decentralization by providing better tooling. Reservoir will be part of that, right? But we want to provide better tooling also for breaking the unnecessary dependencies, allowing people to manage their packages in a better way. We want to provide a module system that allows you to specify clear interfaces between the modules. This is a way to fight against unnecessary dependencies, right? And being immune when something changes, some random feature or private thing changes in a module or a package, it doesn't break you that are using this module and should not be affected by this internal change. Deliverables, right? I'm not going to cover all the deliverables. I mean, it would take several hours to go in detail over each one of them. I welcome you to go over the roadmap. Feel free to ask questions on the Zulip channel, right? We will try to address them in the next community meeting. And there are some components that we did not cover today, like the website. We want to polish the website, the code generator, the debugger, and so on. Finally, before Joe goes into the standard library, let's talk a little bit about the RFCs, the pull requests, and external contributions, right? We have, if we search for RFC on GitHub, you're going to see there are 60 open RFCs and 25 closed. This is a rough approximation. But the ball is rolling, right? We had successful RFCs, like this, the example I have here on these slides, right? It was an RFC, everybody agrees this was great. Many people in the community was asking for this feature, the PR came, had to be polished, but after 1 month, it has been merged, right? There's several other RFCs that are actually being developed right now, right? And they're going to be merged. But I want to remind everybody, the first year we have to be laser focused. We have to make sure Lean doesn't have tons of paper cuts, right? And usability problems, right? Another reminder is that a few thumbs up is not equal. It's not. You should not assume just because there are 3, 5 thumbs up, 10 thumbs up. This is strong community support. Strong community support is way more than that, right? And you have to see the prioritization, right? When we decide to work on something else is moving down the priority list, right? We do pay attention to mathlib high priority, to RFCs tagged with mathlib high priority, right? And we are planning to add more automation on GitHub to streamline their RFC and pull requests process, right? This is going to get better. It takes time, but we are working on that. Now, I'm going to stop sharing, and Joe is going to take over to talk about the vision for the standards library, right?
Is there
Joe?
Yes, hi everybody. Let's see. I think I need permission to be able to share my screen.
This permission, where, Joe? From us or from your Mac?
Let me see. I think
I am allowed to share.
should work now.
There we go. Just got it. Thanks.
Great.
Okay. Okay. Can folks see me?
Yeah.
Hi everybody. Yeah. Yeah. So my name is Joe. I joined the Lean Fro about a month ago, but I've been active, sort of using Lean since I think the Lean 2 days when I was at Gawa. But now I have a job where I'm able to work full time on it, and I'm really excited to be talking about the standard library today. So what Lean Standard Library, it's STD4 if you haven't seen it before. It will provide all the sort of the opening environment for users that they cannot rely on. It's designed for the entire Lean user base, not just mathematicians, but of course mathematicians are a key part of the Lean user base. We want really good beginner experience, so good documentation. We want it to be stable, fast, in that the operations we have efficient executable runtime, so you can sort of depend on them both for verification and for efficiency if you're writing code that you want to use in a sort of more production-ish environment. And it's verification focused. So we do want, for the operations we have, good support from a verification standpoint in terms of lemmas, tactics for those operations, if that will help. But we really want to focus on both, the programmer and the verifier in the standard library. This is still in development, but the idea as it matures over 2024, the Lean core library will be basically people who want to develop on Lean or to contribute to the standard library, and standard will be the default environment for everybody else. So that's the things that go into standard are the things you want in your programming environment, and that can include a broader set of things than is currently in Lean core right now. I will be leading the effort within the FRO and the standard library, but I want to first acknowledge that the standard library itself exists because in Keyzone 2022 we recognize kind of a need for that, as opposed to just pointing every developer at the MathLib itself. And Mario stepped in as a maintainer and has been actively working with people in the community as part of being the maintainer of standard, as well as the various other things he does in the Lean community. And a lot of it does pull from MathLib and other people working often on the Lean community. So it doesn't exist independent of MathLib, other than, in the sense of it's getting contributions that have been tested in MathLib and found to be useful. But we want to target kind of all the different potential disciplines and people interested in Lean. So kind of what does it consist of? Well, it's a Lean library. It has additional declarations and lemmas on basic types. Here I'm thinking natural numbers, Booleans, quality, all sorts of sort of fundamental types. There's common data structures with operations and lemmas, so you can both use those data structures and verify properties about them. Type classes and other abstractions. Here we're I want to say Lean in the sense of we have relatively few type classes compared to say the Haskell type system with monoids and algebraic hierarchy, and part of that is because that is so fundamental to the mathlib sort of world that right now that most of the sort of algebraic hierarchy type things live in mathlib. We also have standard itself doesn't have operating system operations at currently. That's all in core, but over time we could envision some of that may end up getting added to standard. And of course, standard they're sort of part of standard for most users, since we don't really necessarily want users to have to learn the distinction between core and standard, at least when starting out with Lean. And then tactics and other commands. So tactics for manipulating terms, cleaning up your proofs, and then highly automated finishing tactics, something we really want to have in standard. And furthermore, we want comprehensive documentation for all the user-facing features, and that's sort of something we'll be working on in 2024 and currently. So in terms of like what should you expect to find in the standard library for operations and like data types and classes, we want standard to be fairly small. And that's because every operation needs many simplification lemmas. Adding an operation to standard, when you consider all the different things we want, documentation, testing, performance, lemmas, is quite a bit of work. So I think if you have like a big sort of component that potentially could be useful to a lot of people, developing as an independent library, and then maybe we decide if that should be part of the standard interface is probably the way to go, because we want the standard itself to be pretty focused on just things that are useful to the broader Lean user base. And now for lemmas and tactics, standard can be a lot more permissive in that tactics, we really want to include tactics that users can, I think what users should know about. Tactics are kind of key to getting proof automation, and so we can be a lot more inclusive, and we want a big, broad set of tactics that are in standard or sort of perhaps require a separate module, but standard is designed to work with a broad set of tactics. And I think one point of view I have is that the simp annotations should be, for lemma simplification, it should be relatively restricted, with the idea that we want to avoid surprising users, but those could potentially be extended in other modules if you want to have a more powerful simp. And so just kind of I've said this already, I think, but one of the key things about the standard library, since we are designing for verification, we do need to include lots of theorems. So if you're thinking about, should I add oh, here's the operation I have, I think it'd be useful to people. You all should think about what theorems you want to have in that, and decide if that's really, once you add all the theorems you need, is that really a small contribution or is it a much larger one? And so right now, for example, we have like about a little over a 5x overhead in terms of theorems versus definitions, just in the data module, which is where the theorems are most relevant. Perhaps we have through automation, we can reduce that ratio, and then standard can be lighter weight for when adding new operations. But currently, I think that number is going to be, without automation, I think that that ratio is going to grow, and they'll have even more theorems for definitions as we sort of look at paper cuts people are encountering and verifying things, and adding theorems is appropriate to help simplify verification. So our priorities for 2024 are aligned with the overall FRO priorities of scalability, usability, proof automation, documentation, and broad application. We really think we really plan on focusing on getting tactics into standard, or adding annotations, for example, ASOP attributes to help make existing tactics more efficient. And so that's really kind of in terms of tactics. Here's what I'm thinking of right now. What we're tracking is Omega, Exact, formerly Library Search, ASOP attributes, an Isabelle Hammers type tactic that will call external solvers, such as first order decision procedures or SMT, rewriting module associativity and commutativity. I think that will help reduce a lot of the simplification rules and make them more powerful. And then more, as Leo discussed, more powerful induction and termination tools. One consequence of that is, as this automation is developed, and one of the reasons we focus on that early is we expect the theorems that we have may change or be removed ideally without actually reducing the expressive capability of standard. So yeah, through the automation, we don't necessarily need as many theorems. And we will work with sort of the MathLib and so on to make sure we don't break them. So in terms of documentation, this is still something to be underdeveloped, but there will be a lean user manual, and standard will be treated as part of the language. So when we're looking at material in standard, like if you think about contributing, overroom fill is really important. The manual will be independent of the code, so it will be a manual itself, but it can pull from doc strings and other contributions. And I think the documentation needs to help. It should help the user consider verifiability, help people understand what are like normal forms for each type, what are tactics that could help with their code, and helping users find the limits they need to find, I think, is one of the sort of novel challenges with a theorem prover versus a programming language. So I think that's one of the bigger challenges. Yeah, and we'll more detail. So in terms of stability goals, I think in the long term, we aim to have standard to be a stable standard library that people can use over multiple releases without breaking things. In 2024, I can't really promise that yet. The introduction of tactics is going to require sort of could break existing proofs. There are some possible mitigations we've been discussing. So one is automatic fixes for simple changes when upgrading. And the second is selective compilation for libraries when you have multiple lean versions. So you can say this library, if we're running an older lean version, it does one thing, it does something else. I've maintained Haskell libraries that do that. It's not ideal, but it can provide stability. And I will say that neither is right now on our immediate roadmap, but if they get enough interest in the community, we can add those and prioritize those more. Yeah, and I think MathLib's done some experiments in automatic fixing. So yeah. So yeah, and standard exists because of contributions from the community, and we're quite welcome. I just recognize that the maintainers are quite busy, and so reviews may be slow. Please don't put upstream to standard on your critical path, but we do welcome PRs and submissions, and we'll try to attend to them as we can. So our overall priority is to get these tactics in, to get facilities for tactics. And really just keep in mind that we do want to have good documentation. We want to have a very good user experience. So contributions that improve the documentation are especially welcome. Contributions that add more things that will need to be better documented or less are going to be more guarded. Yeah, and so I think that's it from what I want to say. Really, the focus is on tactics and on making this library more mature.
Thanks, Joe. Before we start the questions, just a reminder, we're not going to have a community meeting next month in December, right? Most of us will be on vacation. It doesn't really make sense to have in the middle of the holidays, but we'll come back with the next community meeting in the beginning of January. But now, please, if anybody has questions, we are thinking about keeping the record the questions, but if people are shy, we can also stop the recording.
Yeah, and you can always ask questions anonymously in the chat as well.
Yeah.
I've got two quick questions for Joe. So thanks for your presentation. So first, you mentioned adding AESOP tags to lemmas in STD. Does STD depend on AESOP?
So currently, ASOP depends on STD. This is something we've discussed some. It would be like one solution would be to have standard either include or depend the ASOP attributes. Another solution, maybe we reverse some of those dependencies, but we haven't really seriously started discussing how to best pursue that. But yeah, that's what that meant.
Okay. Another thing is, I think having support for automatic fixes would be really great for Mathlib too, because this is one of the scalability issues of Mathlib. Mathlib is constantly changing. Things are refactored and proofs break, and so right now we manage this, but in the long run, we will really need to have a better tooling for automatic updates. So I think this is not urgent, but this is definitely something worth thinking about and very non-trivial.
Yes. Yeah, there's some work on de-elaboration planned, I think, in 2024 that may help with that. And the other thought is I've heard that the Mathlib had some work along those lines with, I think, the alias command. And but yeah, if Mathlib finds things useful, we love to sort of generalize them and polish them and upstream them to standard on that.
Just to clarify, yeah, we're recording these questions and will, of course, make them public along with the complete video on YouTube. So if you don't want that, ask your questions in the chat, or you can, yeah, do a round of off-record questions at the end.
There's one question in the chat about plans to add cache support for lake packages. Yes, we have. We're planning to have that. Our goal is to have all packages that are, if people register their packages in the future on Reservoir, you get cache support for free. That's the goal.
Yeah, and
Jeremy?
just to emphasize as well, like this is not just for programmers that have their many small packages, but of course also for mathematics projects on top of Mathlib that should also have their own caches. That very, yeah, just having the cache for Mathlib itself is not sufficient.
Hey, this is Mario, not Jeremy, but I wanted to ask about for your tracking metrics. I think another useful metric would be the number. You said the number of packages, but I think also the number of lines of code of Lean in just all of all the Lean packages.
Yes.
And in particular, how much of all Lean code is Mathlib code. I'm not going to say whether that number going up or down is a good thing, but I think it's an important thing to keep track of, like to get a sense of exactly where things are going.
Yeah, this is an excellent suggestion. Thanks, Mario. Should we stop the recording? Maybe.
Yeah, let's wait for, yeah, I think when we stop it, it's probably not easy to resume it. So if anyone wants to have an on-record question still, so we can maybe wait for 1 minute.
There is a question. Yes, there's a question about how can I understand the Lean code base? Wow, yes, we're adding more and more comments there. I mean, I would, if someone wants to understand the code base, I think one good way, first is to read the metaprogramming guides that the community wrote, right? So I think it's a good starting point. After you read the community guides for metaprogramming, start getting go-to files like the Lean root directory, where you have the environments, the expressions, declarations, and so on. Then start going to the meta directory or the parser, depending on where you want to work. Yeah, it's. I think the guides, the metaprogramming guides, is the starting point, but it's going to be a fun journey Someone who is saying here, OpenQ, the improver community. What's oh, it's you, Pat.
Yeah, I know. Like Google decided that I was the Improver community for some reason.
I
I
see.
guess I'm logged into the Google account of the Improver community.
Yes.
Sorry about that. So since there were not that many questions, I wanted to ask: are there any news from the trying to have lean and not recompiling the beginning of the proof when you're editing a 100 lines long proof, and the thing they were experimenting with safe command, but something
Yes.
work more and be automatic, because for big proofs this is really the main usually issue.
Yes. Yeah, I think Sebastian will be able to make a demo in the next community meeting for this feature. I mean, it will show up. I mean, I think
Yes.
we have a proof of concept right now. Sebastian demoed a proof of concept, but in the next community meeting, hopefully it will be released. I mean,
Oh, that's great. Because that's great both for our, advanced adventure in research level mathematics, but also for teaching, because students, I don't know where they find them, but they find computers that are really barely computers, and everything is painful because they have such slow computers, and there's nothing we can do about it except for fixing this issue.
yeah, structure verification is the same problem, right? So, I mean, many of us in the past had this problem. I don't know if you remember Daniel Selson was verifying these machine learning algorithms in Lean, was painful. Clamart also plays with Lean, had painful experience. So yeah, this is an important feature. We hope in the next community meeting it will be there. Sebastian will be here making a really cool demo.
Yeah, great.
Okay, great. When will the packages repository be available? I wish I could say next community meeting, but let's be realistic. May take a few months. Hopefully in the Q1 of 2024. But the answer I want to give is next community meeting, but I'm not sure if it will happen. Will Lake support? Oh,
I would say that is the target. Next community meeting would be the target. It should be.
Cool.
At the very, it might not have every single feature available at that point, but it should be there by the next community meeting.
Awesome. I'm glad we're recording. This is great. Will Lake support some form of versioning for dependencies soon? Yes. I think internally we're talking about semantic versioning for packages. This is really important. Yes, we will have support for that in the future. Plan to allow features like Lake. Okay, is it planned to allow features like Lake updates to stable releases only for users who don't wish to pass RC releases for their projects? Any comments, Mac? I mean, did you any for this question?
That one would be a bit harder because, like, for instance, like if one of your dependencies is Mathlib won't let you just go up to the next stable release unless you're only on the stable branch of Mathlib. So Lake Update that is planned. Lake Update will inspect tool chains of dependencies and attempt to do something smart with that, but that will probably be based on what the versions your dependencies are on. So if you want it to just do stable stuff, you have to have dependencies that have some form of stable branch that only goes to stable releases. Because if they depend on a release candidate, it's not like they can really easily tell whether or not it's safe to update to the following stable release, or if it really only supported that release candidate.
The next one, Mac, also for you. I mean, for foreign functions, for sure we want to support that. I don't see in the first year it is happening unless you're super optimistic, Mac, about having support for that.
One of my hopes for Raspberry's cloud stuff is that it will be at the very least compatible with what the current Lake upload does. And Lake Upload currently just tars up your build directory. So if you stick binary packages into your build directory, they will get tarred up. So assuming that Reservoir does as planned, support everything that Lake Upload currently supports, along with stuff that Lake exe cache does, yes, that should work in the future. That should continue working going forward in the future and be storable on Reservoir. That's the hope.
Another question for you, Mike.
So yes, there's a question about being able to do more detailed versioning in the form of per file versioning, like actually using the reproducible traces that Lake has to determine what things need to be rebuilt, what things don't need to be rebuilt, and version based on that. But that will, doing anything like that would require the module system and more information from the Lean code itself about what versions things are. And right now, that's also a long-term project. So short-term standard versioning is the go-to, but long-term it would be cool if Lake and Lean could collaborate to do some more content-based versioning. But that's a very, very long-term project, I would assume.
Any news about Olin size, right? For teaching and web use, the size of Mathlib in Lean 4 is a real issue. Oh, Patrick. Yeah, well, there's one part will improve, right? We have been discussing in the past about compiling code on demand, right? I mean, there are many, especially for Mathlib, right? There's a lot of byte code there in the Olin files. Probably a big chunk is this byte code, and nobody uses this byte code, right? It's just overheads there, right? We talked about compiling things on demand that would improve a lot the Olin sizes, right? Especially for projects like Mathlib. But there is one cool feature in Lean is this memory mapped files, right? For the Olin, that we can bring them into memory very efficiently, right? But there is the overhead of the size, right? This is probably not going away, right? We discussed it as probably as having a hybrid approach where you could bring serialized packages and deserialize and create the memory mapped files locally, but it's not a priority for us today.
I actually have.
I think
regarding that. I mean, so a lot of the developments in the LTAR format could potentially be upstreamed such that they were. The idea would be that you would store compressed, more like there's some kind of serialized format that's being mapped rather than like actual bytes, and then you would have to interact with that not as just actual Lean objects, but through some kind of indirection. And this would be useful for parts where you don't actually need to inspect the contents that often, like proofs or other parts of the file that are just not helpful in memory. And then if you had something like that, then the on-disk size would also be a lot less. And like even without compression, LTAR has like about a 6x improvement over Olin. So I think that it would be a major win for, especially for people using Mathlib and having to deal with these large Olins. I think that can be significantly improved, but I haven't written an RFC to that effect.
Yeah, we hope to see improvements in the future, right? But for us, the really important thing at least for the first year of the flow is try to address the paper cuts, right? I mean, we know that the size of the Olins is an issue, but it's not blocking or people are preventing new people to come into the community, right? But for sure, it will be improved. Are there plans to include the Mathlib4 docs into VS Code extension? Currently, that's one of the main reasons to leave the editor. Yes, great points. I mean, we should have them there. Actually, it would be great if we had a solution where every package, especially Reservoir, has support for the doc chain there. Doc chain is being executed automatically. And we don't have documentation for all packages registered in Reservoir, and VS Code has access to all this information. Right? That would help a lot, so I agree. Any final question? We have 3 minutes. 2? No? Since the last question mentioned Moogle, right? One cool thing that we want to have in the future is better support for people plugging in their large language models in the VS Code plugin. I mean, that's an idea that Scott was pushing. And yeah, I think it would be great to make it really easy for people to attach these large language models to the VS Code plugin for Lean.
I'm gonna also ask Monte's question. Do we have to include STD in order to use it? I think that's going to make it feel more external than if it was, and also related to that, will it be distributed through Elon so that people don't have to like download it from somewhere else and it feels built in?
Yes, I agree. Any other questions? Okay, everybody, thanks a lot for all of you for coming. Does Moogle plan to include an extension soon? I'm assuming you're talking about Moogle, is the 8 from morph.so. I mean, I think better to ask Jesse about his plans for Moogle. I mean, Joachim developed Slugo, that's a more standard search engine. Okay, everybody, thanks a lot for coming. See you all next year. Happy Thanksgiving and happy holidays.